Hello, everyone, and thank you for joining us today for this webinar series, Digital Hydroconnectivity. This is a 5-part series, which will continue each week at this time until November 30th. This is the first talk in the series, and all of these talks will be recorded and posted on the CUAHSI YouTube channel to view later on. Before we get started, I wanted to give a little bit more information on CUAHSI, who we are and what we do. Here are some of the upcoming webinars in the series. My name is Julia Masterman. I'm the Education and Outreach Specialist for CUAHSI. CUAHSI is the Consortium of Universities for the Advancement of Hydrologic Science, Inc. And our mission is to advance water science by strengthening interdisciplinary collaboration, providing critical infrastructure through our data services, and promoting education in water science at all levels, in part through programs like this Cyberseminar Series. We seek to accomplish this mission in 2 main ways, through our community services and our data services. Our community services include things like grants and fellowships, workshops and trainings, the National Water Center Summer Institute, Cyberseminar Series, Virtual University, and the Hydrology Guest Lecture Database. If any of these things in particular catch your eye, I recommend checking out our website or reaching out. I'd be happy to chat more about any of them. A couple upcoming events or notes. We are currently accepting proposals for training workshops. So if there is a specialized topic or method that you'd like to share with the water science community more broadly and host a workshop, we're accepting proposals currently until mid-November. So if you have any workshops in mind, this could be a good venue to present them. We also have multiple funding opportunities that are currently accepting applications. The Hydroinformatics Innovation Fellowship application deadline is November 19th. And this fellowship enables scientists to create hydroinformatics products to be disseminated with the CUAHSI community. The website for this program in particular has some examples of what programs and projects have been funded in the past that I would encourage you to check out. They've been extremely varied and all quite interesting. The Pathfinder Graduate Student Fellowship is also accepting proposals soon through this December. The Pathfinder Fellowship provides travel funding for graduate students to add a new site to their research. And we're excited to be able to be offering that again now that folks are traveling for their research again. The other side of our house are our data services, and CUAHSI provides tools and support to enable really every aspect of the data lifecycle, in part through our 2 main data repositories, HydroShare and HIS, or data.cuahsi.org. I'd encourage you to reach out to us, follow us on Twitter, join our Slack channel, and definitely sign up for our newsletter. If you have any other questions, my email is there as well. Feel free to reach out to me. Also, if you are going to be at AGU, CUAHSI will be there as well. Feel free to stop by our booth, and we'd love to see some of you. And with that, a few logistical things in terms of the webinar itself. The webinar is being recorded and will be posted on the CUAHSI YouTube channel later this afternoon. Secondly, we ask that you use the Q&A functionality to submit questions to our panelists. Maybe take a moment to familiarize yourself with where that is on your Zoom interface right now. And finally, we expect that all involved with CUAHSI Cyberseminars promote and maintain a professional, considerate, respectful, and collaborative virtual environment. So thank you for being a part of that. Thank you again for joining us, and to our conveners for putting together a fantastic lineup of presentations, and for our presenter today for joining us. Today's session is on open linked water sensor metadata. And with that, I'll pass the mic to Sudarshana to introduce today's speaker. Thank you.
Thank you for the introduction, Julia. So once again, thank you all for joining today. I'm very excited about our talk today. And as Julia mentioned, we'll be monitoring the Q&A in Zoom throughout the presentation and save them for the end. So I'm pleased to introduce our speaker today, Kyle Onda, who is a data architect at the Internet of Water, in Nicholas Institute of Environmental Policy Solutions at Duke University. His research focuses on urban planning, infrastructure sustainability, and hydroinformatics, to name a few. So without further ado, I'll turn it over to Kyle.
Thanks for that introduction, Sudarshana. Let's see. Does everyone see my slides correctly?
Yep, looks good.
Okay, great. So hello, everyone. My name is Kyle Onda. I'm the technical lead of the Internet of Water project at Duke. I know the title of this talk was about open water sensor metadata, and I'm presenting about this project called geoconnects.us that I work on in collaboration with the USGS. That includes water sensor metadata as a key pillar, but is really generally about the persistent identification of structured metadata about all hydrologic and hydrometric features, which I believe is an important element for the maintenance and usefulness of things like hydrologic dependency graphs that will be discussed in later seminars in this series. So without further ado, I'll get started. So I'll start by just giving you an overview of what the Internet of Water is, which many of you may have heard of. So it's really three things. It's a general vision for a modern water data infrastructure throughout the United States, consisting of a network of data systems that can provide seamless access to water data to users and to each other. There's also a community of practice consisting primarily of data providers, including federal and state agencies and NGOs and academics that are trying to implement this vision. Many of these organizations are represented on the board of advisors of the project, which is currently at Duke University. And this project that I work for provides social infrastructure connecting this community of practice, as well as educational programming and technology that supports the effort. So in terms of the Internet of Water, the idea is there's data producers whose data is aggregated and standardized and served by various hubs that can be easily linked to each other, so that a user going to one hub can pull in relevant data from other hubs according to their use case. Among other things, the Internet of Water project is pursuing this GeoConnects project as the technical framework that actually can link together these hubs. So the primary motivation here is basically one about data discovery. So GeoConnects comes out of this stream of work at the Open Geospatial Consortium called the Interoperability Experiments. Dave Blodgett from USGS had a leadership role in these experiments, and the lessons of which formed the core ideas behind GeoConnects, and I worked directly with him on this project. He also expressed the general motivating user story. So as a user of water data, I need to discover and access water information relative to an environmental feature I care about from all organizations that hold data about it. So I don't need special knowledge to access some information, and so I don't miss potentially relevant information. And basically, I want all the data, but I don't want to have to know where it lives ahead of time. Taking things a bit down more to hydroconnectivity and the other talks that will follow mine in this seminar series. The motivation is we want to be able to quickly aggregate hydrologic relationships between features that are being calculated by numerous scientists and user groups. And we also want to maintain the usability of all of these dependency graphs over time. So as a motivating concrete example, right, we have the motivating use case of the network linked data index of USGS, right? When USGS was asked to provide historical water quality data from all sites they had downstream of the Gold King mine spill. And it took GIS people 2 weeks to compile this. Now with the NLDI, which indexes everything to the NHD plus version 2 flow network, a similar request could be fulfilled in about 2 minutes with 2 REST API calls. But while the NLDI allows you to discover content, it doesn't provide a standardized template for that content or the metadata. And so the idea of GeoConnects is we want to standardize, extend, and stabilize this search. So we want to be able to catalog data from the community to make their data discoverable within the context of the stream network. We also want to provide persistence for links to data from ever-changing data systems that are contributing to this. And we want to provide a framework to publish and use non-explicitly geospatial relationships between data and features of interest. So I'll run through a quick vision of what I mean by these three motivations with reference to the Gold King mine example. With the current capabilities of something like the NLDI, you're able to find all of the NWIS and water quality portal sites downstream. But there's a lot of other data that one might be interested in. For example, a mine spill would also be relevant to water rights holders along the Animas and San Juan River. The Western States Water Council Water Data Exchange, or WADE, is an organization that aggregates and publishes water point of diversion data from the 17 Western states. So we've worked with WADE to publish their metadata in a manner that it can be indexed to the NLDI2 quickly without needing to go through the entire NHD stewardship process. So now this rich external data is discoverable alongside WQP and NWIS data. Second is we need persistence. The NLDI, or the nodes of any similar dependency kind of graph system, provide what amounts to list of identifiers for sites, which human and machine users follow to collect the actual data of interest from. In general, URLs are a useful form for an identifier since they can refer users directly to much more detailed information available elsewhere. However, URLs change all the time. So to provide a robust data discovery framework, the URLs need to be persistent, and GeoConnects is supposed to provide a persistent identifier registry so that these data connections can be maintained. In the WADE example, this persistent identifier in green redirects to the actual, in this case, fake URL. WADE administrators can then use the GeoConnects registry to update the targets of their redirects if and when they change their URL pattern, while users and administrators of the NLDI don't have to worry about changing anything. The third major motivation is to support connections between water data sets that are not explicitly geospatial only. For example, one might want to know the service areas of water systems that would draw water from the 12 units along this stretch. Given sensitivities around publishing water supply intake locations, this is not a direct association that could be recovered by something like a geospatial intersection, but an indirect one is an association that can only be publicly expressed in a non-spatial way. Such linkages extend to how to link out to data about the same site from multiple data providers, as is the case with, say, drinking water testing data, which might be provided for different parameters and time steps by federal CIDWIS and state and tribal agencies, or the utilities themselves using their own monitoring networks. So GeoConnects is about creating enabling conditions for maintaining a knowledge graph of water data. In this stylized example of a hydrologic system with two reservoirs connected by a stream with some monitoring locations on it. The first thing we'd want to happen is for each monitoring site and environmental feature or sensor should have an internet representation, a website about it, a landing page, which would be directed to by persistent identifiers that can be updated. Those landing pages should include structured machine readable metadata. For example, a dam might have metadata that standardizes how it describes itself, declaring itself to be a dam from a controlled vocabulary associated with particular water bodies and streams, and linking out to monitoring data relevant to it. Since many locations might have different data sets about it from different providers, it would also be good to have persistently identified reference features that are kind of community owned and aggregated that multiple data providers can declare that they have resources about. Such features include monitoring locations, watersheds, administrative geographies like counties, and pieces of physical infrastructure like dams. And then finally, we need some kind of mechanism to tie all of these independent metadata records together and infer sort of the transitive linkages that happen when you do so. A suitable technology for this is some kind of web crawler, which commercial search engines have been using for 2 decades to do analogous indexing and creating tools to discover information on the World Wide Web in a broad sense. And we just want to kind of apply this and systematize it for hydrologic science. So I'm going to just dive a bit deeper into each of these requirements. First being landing pages. Right, so this is an example landing page, in this case for a dam operated by the Bureau of Reclamation and published in their RISE information sharing environment. So ideally, this dam would have its own website with a bunch of human readable information about its basic characteristics and its location and where time series data from sensors relevant to it can be found. Ideally, this page would be reachable via a persistent identifier so that Reclamation can change its website but avoid link rot. This would be the persistent identifier, which is cut off at the top of here, but you get it. It would say like, it's the same point as before. Finally, we also want this information to be expressed in embedded, standardized, machine readable versions of the same information. The idea is to use technology familiar to web developers such as schema.org and JSON LD markup. The type of information includes the site's, the site's name, its persistent identifier, what it is, so a dam and a hydrometric station, its hydrologic address using persistent identifiers for, say, NHD plus V2 features. So it says it's at this HUC 12, it's on this flow path identified by this COMID, as well as just the literal latitude and longitude. And then as well as have links to where to access the actual time series data from the data systems API, right? So it's a feature of interest of these observation collections. The idea is to use controlled vocabularies that have been developed as part of data standards like Water ML2 Part 3 for hydrologic features and SOSA and SSN for the semantic description of water sensors. Ideally, these documents would also include a reference to the reference feature that they are about. So for example, we want there to be a reference feature set of all of the dams, right, nationwide, whether they're in the National Inventory of Dams published by the Army Corps or not, right, those smaller dams. And that way, other organizations, any organization publishing data about these dams could reference the reference dam. So how do we GeoConnects us, geoconnects.us? So this is an infrastructure that's under active development and collaboration with USGS. We want to provide the infrastructure necessary to create a hydrologic knowledge graph under community contribution model. So I'll go over what infrastructure, community, and practices we have in place so far. We are currently supported through a combination of USGS WRRI grants and philanthropy that together have guaranteed support through 2026. And we're also under active discussion to integrate programmatically in the long term with the National Hydrography Infrastructure, or the 3D Hydrography Program. So the first thing that we are is providing is an open persistent identifier registry. So if a data provider has web resources, websites about hydrologic features, we provide this as a free service. Currently, we run this through GitHub. So minting identifiers basically involves forking the repository, opening a pull request that commits to the namespaces directory. Organizations like CUAHSI, EPA, USGS, the New Mexico Water Data Initiative, Oak Ridge National Labs can create their own namespaces by adding subdirectories, which can have a number of CSV files. So CUAHSI has a lot in there. Most of HIS has identifiers. These files are simply tables specifying the desired GeoConnects persistent identifier, the target URL that it redirects to, and some optional administrative metadata like the contributor. To merge a pull request, we also require there to be a brief descriptive README file in the organizational namespace so that administrators can understand what the contribution is. So in this case, USGS has registered and described identifiers for hydrologic units and monitoring locations in NOS Web. And we've automated the system a fair bit. So once a pull request is approved, persistent identifiers populate the server and become active within about 5 minutes. But we are exploring development of a more self-service model that wouldn't require this GitHub pull request thing, similar to Perl.org, where providers can register their namespace and then kind of actively edit their identifier lists as they see fit. I mentioned before our need for reference features that are community owned, but can be the subject of any data provider wishing to provide unique data about a location of interest. We have begun laying the groundwork for this with our reference feature collections. So these collections have a special reference namespace that's either associated with an authoritative collection of features, such as census geographies, the HUCs, national aquifers, public water systems, as well as open source collections of features that are collated from all available vetted sources. So for example, the reference gauges namespace is populated from a combination of USGS and state databases. And the code and workflow that produces that set is available to the public at a repository that's currently administered by Dave Blodgett at USGS. But the idea is we'd want similar open source projects for other kind of reference feature sets, like dams, levees, culverts, monitoring wells, and so on. The reference features themselves are hosted at this website, reference.geoconnects.us, which serves out these features via the OGC API feature standard. It offers HTML, GeoJSON, and JSON LD representations of each feature. So since it's doing that, it also serves as a demonstration of the practices that we are trying to promote with persistent identifiers that redirect to landing pages that include both HTML, human readable, and JSON LD structured metadata, including links to data where available. Third, we're trying to build a community of practice. We are still figuring out exactly what the JSON LD needs to look like in these landing pages and how best to publish this sort of content. So we welcome discussion both in the GitHub issues of the main repository and a channel we've created in the ESIP Slack, so ESIP being Earth Science Information Partners. We're currently engaging with partners from federal and state agencies, CUAHSI, and projects like the Urban Flooding Open Knowledge Network, community science organizations like the Water Data Collaborative, and are always looking for more engagement. Fourth, we maintain a version of PyGeo API, which is an open source Python server that's designed to serve out spatial data with OGC standard APIs, API standards. We use this as an option for data providers without an existing spatial data infrastructure to generate these sort of landing pages with embedded JSON LD from static geospatial data sets like just GeoJSON or GeoPackage files. But they can also proxy things like Esri feature services. So this is what reference.geoconnects.us is based on. We've assisted New Mexico agencies and Oak Ridge National Labs, for example, with standing versions of this up. Finally, as part of the WRI grant from USGS, we are deploying a harvester to create the knowledge graph. The technology stack we're using is based on one developed for indexing structured metadata as part of the NSF EarthCube project. I believe it's almost the same thing that's underlying the Urban Flooding Open Knowledge Network as well. At least the metadata index part of that. We've already deployed it on a small sample of just our reference features so far to iron out technical issues. But we plan a full deployment to be in place with some sort of knowledge graph to actually browse for the public by May 2022. But anyway, early results have been promising. The basic system and architecture works. For example, we've inferred linkages between public water systems whose service areas split the same municipality and collated the links to the EPA drinking water regulatory data about those systems. So in terms of the big picture of how we see the system working is we have the persistent identifier registry. And this already exists now. You can go here. Every time there's a live connection between these two resources. So anytime a new persistent identifier is contributed or edited or deleted, a sitemap is updated. So a sitemap is sort of just this nested list of all of the persistent identifiers in the system. And so these persistent identifiers are the reference features are directing to their landing pages, and the ones that are organizational namespace are redirecting to their landing pages. And these all, hopefully have a lot of rich relative links to each other embedded in their JSON LD. And so the idea is we can then send our web crawler to that sitemap. So it will go to all of these landing pages, gather up the JSON LD, and we're storing it in a sort of an RDF triple store so that we can infer all of the various relationships. We will be providing the entire bulk knowledge graph, as a public domain kind of data set available for download, as well as a Sparkle endpoint for kind of interactive queries. We may, in the long term, have to put rate limiters in front of this or charge access for it for cost recovery, but the knowledge graph itself will always be public domain. The harvester and the triple store will be using free and open source software, so they can also be just deployed on your own to make your own knowledge graph. But that's what's in place, but we still have a lot of work we need to do to make this usable. So for example, for a use case where we want to discover all sensors upstream of some point, but bounded within a HUC gate and with data on two specific parameters within a time interval from all organizations. We need a lot more than what we've already put together. The JSON LD markup is still under development and needs to be iterated with partnering data providers. Again, a lot of the work will be based on the OGC interoperability experiments, which are referenced at these two links. And we're still developing templates and also more interactive documentation to help data providers do this. Our 2022 WRI grant includes resources dedicated to developing templates in the form of shackle shapes and JSON schemas for stream sensors for both stage and flow and water quality parameters, whether continuous or discrete sample type. Similarly for monitoring wells and then for dam reservoir systems. The critical elements we need to hammer out are to enable that kind of use case, what sensor or procedure metadata there needs to be, or even how to distinguish between observed data and modeled data and all the various model runs, and how to describe those models, or at least point to metadata about those models. We also need to, finalize how to specify a hydrologic address if you have it available, and provide detailed guidance on how to go determine a hydrologic address if all you have is the latitude and longitude. And then also how to specify parameters and observed properties and the periods of record associated with all of them. So we want to know what that sensor has measured and when. And then how to provide structured links to real-time and historical data or model runs, and how to specify kind of the API standards if there is an API for how to go get that data in an automated manner. So thank you. I managed to compact this pretty briefly. So I'll just open it up for questions and encourage people to reach out in other ways. With that, I'll stop. Okay, it looks like, does groundwater fit into the GeoConnects model? So yes, we have one. So we definitely want to have that template for monitoring wells, for example. We also envision eventually we want some mechanism to publish reference features for kind of aquifer shapes, and then have persistent identifiers for those, and have some sort of way to specify, what aquifer or part of an aquifer a well has data about. All right. So one aspect that is often underfunded once the data is cataloged and standardized is maintenance of that data, including improvements, changes in time, expansions to include new data sources and hubs, avoiding outdated or old data. How's maintenance envisioned in the long term? Do you envision funding for centralized maintenance to GeoConnects or distributed to the hub? Okay, so the maintenance of sort of the persistent identifier registry is envisioned. It needs to be kind of funded indefinitely. That's what I'm talking about with kind of getting programmatic, having a programmatic partnership with 3DHP and the National Hydrography Infrastructure. But part of the entire model is it's actually decentralized. The data governance is decentralized. So really it's data providers that are responsible for providing these resources. We're just simply crawling it. And we actually think that's a more sustainable model than a centralized database where you're actively kind of going out and grabbing all of the data from data providers. This is how the rest of the internet works. Google isn't actively, building the database of everything in the sky manually, right? People contribute to it by just publishing structured metadata. So that's really the inspiration for the model. But that being said, there are going to be struggles around data governance, desires for maintaining and vetting kind of the quality of metadata. We need to create, and we do have in the pipeline, sort of creating validation mechanisms so that if someone contributes a persistent identifier that is pointing to sort of malformed metadata, that we have some mechanism for contacting that administrator to tell them that. So we do foresee a long-term kind of home for that aspect of GeoConnects governance. How do I balance the desire for standardization with flexibility for metadata requirements? For example, if research begins to show other categorization methods or ways to show information, is there a fear or preference for lock-in or some foresight or flexibility? Yeah. So we're going to have these templates and certain validation rules, but yes, it's actually designed to be fairly flexible. I mean, very similar to schema.org. So the template system, the control vocabularies involved will all be, that will always be a public thing that's open for discussion. for submitting issues, resolving them. We very much view this as a continuous kind of indeterminate work in progress. And there's going to be complex feature types, a stream, like a location might be the location of a dam and a stream gauge and a water quality monitoring location, and who knows what else. And so there needs to be kind of aspects for multiple typing of things. And we are thinking about that deeply. How is the GeoConnects connection maintained as unique IDs change at the data source? Will each system data set have a persistent ID, or will they be combined where they overlap or exist within a certain instance? Right, so the idea is it's the responsibility of the data source. So if they're changing a URL pattern, they need to update at the URL, at the ID registry, the target of their redirection. If you're saying the actual data itself changes, yeah, we are thinking about, for now, we just control the crawler and we can kind of hit go again. So there's a certain kind of very human analog aspect to that at the moment. When we move to that more Perl.org type self-service system, I would want on the roadmap there to be where someone, a data provider who knows they've updated their metadata, can request a recrawl of their resources. Just like a webmaster who has a bunch of domain names who wants Google to crawl it can request a recrawl. What kind of internet technology do you use? I saw a model that was waterproof, but I think Wi-Fi doesn't go below a certain water depth. Can you talk about? I'm gonna have to confess, I'm not sure how to answer this question. I don't know if it can be rephrased. In general, the only thing I want to know about water sensors is sort of metadata that's needed to describe how that sensor, so that a data user can understand if that information is fit for whatever use case they have in mind. How do I connect to the sensors that collect data to the internet? Right, so there is a whole IoT world. I mean, there's lots of data vendors that, yeah, it can be any number of things, right? So a sensor that collects data that isn't connected to Wi-Fi or cellular, it's fairly common. It just has a data logger, and eventually it goes to a pickup truck, which goes to an office that has a laptop on it. And it gets put in some database. The key point, or there might be just internet connected sensors that are directly posting via some API to some cloud-based database. The key point is how it's harvested is that those sensors have internet resources about them. That connection doesn't necessarily need to be live, but it needs to be institutionalized in some way. And then also, GeoConnects is primarily concerned about metadata, but the data itself, ideally is going to some web published resource where it's available for download in various formats. And those URLs we would like to see in the sensor kind of metadata.
Okay. Thank you, Kyle, so much for your talk. And thank you everyone who attended and for any questions. If you have any additional questions, you can keep putting them in the Q&A. We had right around 40 attendees here today. So thank you everyone for joining us. And if there's any other questions, they can come in now.
We have one more question. Yeah. How do you see persistent IDs and GeoConnects working with DOIs and changing data?
Yeah, so DOIs, there's a couple different aspects to this. So first, good to point out the analogy to DOIs. One reason we embarked on this at all is it becomes cost prohibitive to create actual DOIs for something on the magnitude of, a sensor network with millions of possible sensors, like the WAIT network, which is aggregated from all of the water points of diversion in the West. But the idea is persistent what's persistent is the identifier for a monitoring location. So the data about that monitoring location can be added to over time, and that should be reflected in the metadata document that that identifier redirects to. I believe there was another question of like, how do you deal with kind of overlapping maybe or duplicated resources? And that institutionally is something we need to explore more, maybe in another round of development with some data providers that we know already collect data about the same feature. But the idea is there, that's what the reference features are supposed to kind of address. And then in addition, we want there to be a mechanism where you can declare a certain identifier is the same as another identifier, right? So then you don't have to change everything else in the knowledge graph. You just add that statement to it, and then all the properties of identifier A, which is the same as identifier B, will then apply to identifier B. Yeah, sorry, I know that was a bit of a tangent from the very last question, but I was reminded of that issue.
I just have one more question. This is like a more general overview sort of thought. So what are the like main challenges in this standardizing and categorizing these data set to form GeoConnects? Like all the sensor data coming from different agencies, and there could be like different format of the metadata. Do you face any like particular challenges in combining them?
Yeah, so there are lots of challenges, right? So to be super duper useful, for example, it'd be great if all these water, say for surface water sensors to have a hydrologic address, you know, to have a reach code and measure that, you know, many people don't do that. It's just latitude and longitude. This is why we're thinking about partnering with 3DHP and the National Hydrographic Infrastructure to sort of create, you know, if not actual integrated workflows, certainly easy to follow procedures where someone could add a hydrologic address to their metadata before publishing it in this manner. Another problem has been, right, which version of NHD, which stream network are you addressing to? And that, right, NHD plus versus NHDHR versus some custom stream network. How do we handle that? And that I'm going to punch to Dave Plodgett, whose talk kind of addresses some of that. I think his is in 2 weeks. A lot of it, honestly, a lot of it has been so far, we haven't even touched the templates really yet. A lot of our challenges have been either getting people to publish metadata in this manner at all. The idea of station level kind of websites with this stuff is foreign to many data providers. And then going beyond that, sort of the arcane art of formatting JSON LD and getting all the references together for that has been difficult. Sometimes things like a spelling error or a punctuation error can throw everything off. And so that's why we do have in the pipeline kind of validation tools, similar to the structured data testing tools that you know, Google provides webmasters.
Okay, thank you very much. Thank you, Kyle, for your thoughtful presentation and discussion here at the end. And thank you all, everyone who attended, for all the questions. I hope you enjoyed. Once again, this will be recorded, and this has been recorded and will be posted on the CUAHSI YouTube channel later today or tomorrow. So if you want to share this with a colleague or you want to review any bit of it, it'll be there. But thank you all for joining, and see you here, hopefully, next week for the next talk in this series. Thank you very much. Have a good one.
Thanks, everyone.